Hello, everybody. Good afternoon, good morning, whatever time it is. This is our June 2020 Ansible Toronto Meetup. My name is Aaron, and I'm joined by my three colleagues, Phil, Chris, and Hart. And they'll have their own introductions for their sections of the day, but we have a few other things to get to just before that. I'm glad to have everyone online, and this is a virtual meetup rather than in person. So again, it's a little different from what we're used to. So welcome back. This is for June 2020. We have still the current world situation where I would like to at least recognize and thank frontline staff for all the work and help that they've done in our communities everywhere. And hello to all the new people who haven't been on the meetup before, and all of the regulars, of course. It's great now. We don't have to be specific to Toronto. So if you're coming from another city or another country, that's great. Hello, and welcome to our meetup. So we're going to do Q&A via the YouTube live chat. So jump in, add some questions at any point in time for any of the speakers, including me if you feel so inclined. And we'll do sort of a Q&A for the presentations at the end of them, but also one mass Q&A at the end if you like. And we'll take any kind of contact for post-event questions or contact via our typical channels for Arctiq. So you can, everyone's I think's posted their social profiles, so you can get in touch with us afterwards as well. And a quick thanks to Arctiq, of course, for hosting everything, Red Hat for helping us with the event, and StreamYard and YouTube for the technology, without which we just couldn't get it done. And thanks for the speakers for stepping up today. So just some quick sort of Ansible community updates. Yeah, we'll work on the pizza. We couldn't get an Uber Eats deal that would send cross border, so we'll work on that for maybe another time or another era. So some really quick news. This slide was ready to go until I noticed yesterday that they released 2.9.10 of Ansible, which is perfect timing for a meetup to have news. So pretty much the most pointed update in that version is that they added the new magic vars for Ansible collection and Ansible role name, which is impressive. It looks like they're preparing to release collections out to the wild officially very, very, very soon. In fact, that's probably going to be what 2.10 is all about, fully adopting the whole Ansible collections piece and specifying roles, of course. And then 2.9.8 and 2.9.9 was mainly bug fixes, security fixes, compatibility, and then some quality of life fixes. You've probably already been using those versions and may not have even known about it so far. As I was mentioning, 2.10 is definitely looking like it's going to be all in for collections. If you keep an eye on the repository where they do the devel, there's a lot of collection specific stuff happening in there. And we had a few talks in the past about collections. So also for specific to Tower or AWX, whichever you happen to be using, 3.7 came with some mainly what looked like mostly performance improvements, a number of shifts into Python 3.6 across many components. They swapped RabbitMQ for Redis, which is surprising. I had no idea they were going to jump in and do that. And then also some quality of life fixes. And as usual, I like to kind of report on what we're seeing in some of the projects that we work on. So we're still seeing lots of ask for Tower and OpenShift and Ansible and ServiceNow talking together, lots of integrations. And we still see a lot of AWX and Tower in pretty much any size environment. If I, Most people on this meetup are probably using Ansible and probably even Tower or AWX in their live environment right now. So without further ado, let's just quickly go over the agenda for today. We've got Chris Markieta talking about AWS VPCs via Ansible. We have Phil Thomson talking about Tower or AWX on Kubernetes or OpenShift. We happen to be, pretty biased for using a whole bunch of OpenShift with Tower. And then we might take a break, depends on what timing looks like. And then we have Hart talking about network automation with Ansible. This is probably a talk that's been well overdue. or at least one that we're trying to keep bringing back because the networking community has been well overdue to get some automation in there, and we want to kind of help nudge that forward. And then we got a little bit more Q&A, and we'll close up for the day. We usually book this until roughly 2 p.m. Eastern. I don't know that we'll go that long. We usually take about an hour and a half. So gauge your own personal breaks as you see fit. So I'm going to bring in our first talk, Chris, and everyone else can take a short break in the meantime. So Chris, could you share your screen and I'll put it up here?
Absolutely. And we should be good to go. Can you see
All
that
right,
okay?
Chris. Yeah, that looks good. Take it away.
Awesome. Thank you, Aaron. So this is probably my first live YouTube conference slash meetup, so I hope it goes well. Um, Thank you again, Aaron, for introducing us. Today I want to talk to you guys about a little bit of my, sort of one of my first project slash onboarding stories at Arctiq. For those of you that don't know me, I'm a regular goer of the Ansible Toronto meetups, and I've been with Arctiq for about 2 years now. And I'm a consultant just like Aaron, Phil, and Hart. I've used Ansible many years ago in the past, just trying to set up my brand new machines and automate the installation process of Fedora or Ubuntu on my new laptops. And so coming into the Arctiq team and getting my new laptop, it was actually a nice thing to be able to just load up my GitHub repo and run the install for my work laptop and get everything the way I wanted to. So I'm glad that still worked. And coming forward, I just had to learn more Ansible that wasn't just the basic stuff of setting up a personal machine, but also setting up a production and real world scenario environment, right? So this talk is one of the projects that I was working on with Phil. I think it was about a year and a half ago, and I was dealing with AWS VPCs and some of the, I guess, not so fun situations that you might come into. A little bit of tedious work to figure out. And so, yeah, today's just, even though I'm a pretty, frequent comer to the Ansible meetups, I think this is my first time presenting, so I just wanted to share with you a little bit of my story. And for those of you that are on the call that may not be experts in Ansible or have never heard of Ansible before, this is not a very complicated talk, so hopefully you enjoy it. Yeah, so going forward here, today I really just want to talk about Ansible, but also do a little bit of a comparison with Terraform. Now, don't take it the wrong way. I'm not trying to make this oh, Terraform is so much better, or Ansible is so much better than this and that. It's not really that kind of conversation here. It's more of, what we're trying to do for this particular customer and tell you how this is going to be, like a little bit of a, I would say, where they can be beneficial in one scenario versus another, and where this could be maybe a turning point for using one tool over the other. Okay, so if that didn't make any sense, don't worry about it. I'll clear it up very soon. So, for example, Terraform, we use Terraform a lot to sometimes just provision infrastructure, and with our case, in this particular project, the customer wasn't very familiar with Terraform, and so they wanted to use Ansible, something that their team was comfortable with and in their wheelhouse. So they knew Ansible, and they wanted to help or get help provisioning infrastructure using just strictly Ansible as much as they can. For those of you that are unfamiliar with Terraform, it's an easy way to provision infrastructure in the cloud or on-prem. And it has this reference to state files that tells you whether or not a particular infrastructure component like a VM or a network is up or not, if it's alive or absent. And in Ansible, we are dealing with more of configuration as code. So configuration management, where we want to apply some sort of config to maybe some VMs or cloud infrastructure, and we do so by running playbooks. And so in this particular scenario, what I was trying to do was, trying to accommodate for the customer's needs to use Ansible and provision infrastructure, which is, again, it's in their wheelhouse, they know how to do it. But we also want to do it in a way that we're used to from Terraform to provision infrastructure or deprovision on the fly, and basically just having a yes or no switch or a create versus destroy switch to choose that option. And so the way that I did that was by doing a bunch of querying of the AWS API, and then also using that to then decide whether or not we need to create something, skip a task, or destroy. Okay? And so let's figure out how we can do that, and I'll talk a little bit about how we did that. So the I would say the main tough point for me was learning Ansible and how to actually write code idempotently. Back in the day, I was still fairly new as a novice to Ansible, so learning how to write idempotent code and in the structure that Ansible is, and trying not to be confused with how to write programming languages. The, I guess, absence of doing a bunch of nested looping logic and conditions, while it's somewhat possible to do in Ansible, is not to the extent as something in Python or Go. But I got used to it, and it's something that I eventually got pretty accustomed to. And so let's see what happens in this next piece here. So my particular task was helping Phil out with creating the VPC provisioning inside of the customer's environment for AWS. Now, if you're trying to provision a VPC in just through the web UI, the AWS Management Console, you can very simply create any subgroups of subnets and NACLs and internet gateways and things like that. And if you want to destroy everything, just destroy the entire VPC and start from scratch. It's easy. You just click destroy on the VPC and it'll handle the dependencies for you and delete the things that you need to, that are nested inside one by one in the order that it's supposed to. One thing that I thought, was going to help with this is, when I'm writing the Ansible playbooks and the rules for the destroy piece, then it made me think, oh, great, I can only just focus on the create and not have to worry so much about the destroy. That's probably just going to be one task to call the API and delete it. But it turns out it wasn't the case. For me, it was actually, I found this feature request that was open on GitHub, and I was getting pretty confident that this is going to be something that's implemented. You see, it was requested on the 2016th, and you've got like 56 thumbs up there. It's probably even more today. So everything was looking great, but I got my hopes up, and it turns out, the teams on the AWS side didn't really want to implement that for some reason, and that was a little bit of a bummer. But we worked it out. I figured out, okay, so it's not going to be a simple destroy, but more of a deconstruct playbook or role. And so I sort of figured that out and tried to work that out. And I tried to draw this little graph flowchart here, which, is just a little fun way that no way really accurately describes what's going on here. It's just, I thought it was kind of hilarious trying to fit this all in one slide. But the idea here is, I'm trying to create or destroy when I run my playbook. And the way I do that, the way I choose that, is simply, specifying an extra var called activity and saying activity, if activity is equal to create, then I'm creating the VPC and all of its subcomponents. Otherwise, I select destroy and destroy everything. So if you can see this hopefully on your full screen, the create playbook or role run is going to check if the VPC is defined in the inventory, and if it is, it'll create any inventory gateways that are defined in there, any subnets, any NAT gateways, and tag them, and internet gateways and things like that, route tables. And it does so in a specific order because that's kind of the way Ansible is written, right? You have to run your code from top to bottom as opposed to Terraform, where Terraform's going to do things with implicit dependencies through all of your different resources. And so when you're doing the destroy piece, because we can't just destroy the VPC and hope everything's okay, the destroy is going to complain that, well, you've got a subnet created, we can't destroy the VPC until you destroy the subnet. But it's not just the subnet, it's everything else you have in there, and you have to destroy them in a particular order, otherwise you'll get an error. So in that case, it was querying the VPC, checking if it's defined. If not, you've already destroyed it, so we can skip this whole task. Checking the VPC's NACLs, and then if that's created, checking the subnets if they're created. And there's just a bunch of different logic blocks there to check to make sure if I've defined that there for this particular VPC versus if I didn't for another, and vice versa. So that's sort of what I solved for in my demo here. Now, I'll show you what that looks like in code. So basically, in here you can see my Visual Studio Code window, I hope. And if not, please let me know. Basically, I've got this one playbook. And in this playbook, I'm specifying a list of hosts or a group of hosts that I'm targeting. In this case, I'm just making it a little bit fun. I'm calling them sandwich launchers. And I guess, I don't know, I was thinking about grade 12 physics class and I was hungry at the same time, so I thought this might be a fun way to demo this. And so in this case, this particular playbook is just running one role, and this role is the AWS VPC's role. But inside the role structure, I have three YAML playbooks here. So the main, which gets run automatically when you call this role, is going to either import the create playbook or import the destroy playbook, whether I decide the extra var is activity create or activity equals to destroy. And I'll show you what that looks like in the command line. It's pretty straightforward. Everything's running on the local host because this is just a AWS call. It's an API query from my local machine. I'm not dealing with any physical machines or VMs or anything like that. That was handled by Phil. He did all the extra fun work. I had to do the VPC stuff. So let's see what happens when we do a create. So create is going to create the VPC, obviously, and it's going to reference all of the variables from my inventory. And you'll notice that I have a lot of blocks here in my playbooks. So I create the VPC first. After that, I can then create internet gateways. And then if I have a block of subnets in my particular inventory in one of my sandwich launchers, then it'll create a subnet for me. It'll also create NAT gateways if I have them, and tags for them to tag it so that it's easier to reference in the cloud later on. Same thing goes for internet gateway route tables and querying the gateways to make sure I have the correct IDs after I've created everything. And once that's all done, and I validated everything, I'm only running this all once, even if I have 5 or 10 different sandwich launchers I want to create. If they all have the same VPC connected to it, then I only want to create one VPC. That's the idea there. And then for the destroy piece, because I can't just destroy the VPC by itself and expect the dependencies to work themselves out and let AWS handle that chain of destroying, I had to do it myself because of that API limitation. So in here, I'm querying for the VPC, getting the ID back. And that's one of the things that you'll see a lot here is that I couldn't just specify my own unique IDs. I had to create the objects first using names and tags and values inside my inventory. And then when I run that, it'll return the ID, the unique identifier. But I can't store that in my inventory unless I'm using dynamic inventory. So that's something that I had to account for. And in this case, it's just a bunch of queries versus right after querying, then you can destroy. So query, destroy, query, destroy. So I'm querying NACLs here. And again, the order in which you destroy them depends on which one's depending on another resources. So the order really mattered here, and it wasn't very clear to me, and it took me quite a while to figure it out. And so it was a matter of destroying NACLs first, making sure that that's destroyed, and then doing the NAT gateways, and then doing the subnets, querying the endpoints, and then destroying the endpoints and things like that. So you'll see it's a pretty long playbook just to get one VPC destroyed, but doing all of those individual steps to deconstruct it one by one. One particular thing that I wanted to, or struggled with, that I wanted to share was that there's a little bit of a design decision that we needed to come up with, and that was because of some of the API conflicts I was running into. So for example, I've got the 3 sandwich launchers that are called Furious Panini, Electric Baguette, and Bond Me. I was just having a little bit of fun here, but as you can see here, I've got 3 environments, and I've got to decide how I want to structure these. Do I want to have one VPC limited to an entire group of sandwich launchers, or can I just specify them in here in each individual host vars, and just let them decide, okay, if Furious Panini and Electric Baguette are part of the European Sandwich Society or something like that, then they can be part of one VPC, and then Bond Me can be part of another one. But in this case, it didn't really work out for me. And the reason for that is, if I were to specify the VPC name and all of the information for the VPC on a per host basis, and I had a duplicate for the band, or rather, the Furious Panini and the other one, if there were duplicates there, if they had the same name, and I tried to create them at the same time, instead of Ansible just creating one VPC, it was a duplicate that was, you've got the European sandwich launchers duplicated, 2 VPCs instead of just one. And so that was an issue for me. It was very odd to see 2 VPCs with the same name, which isn't really allowed in the AWS console when you try to do it manually. But because I think they were done at the same time, you had that conflict, and it became a huge issue for me. So I decided, okay, design decision, let's just create sandwich launcher, or do it by a group sort of convention, where in my case it was, in here I'm going to specify VPCs per group only. And if you want to create a different set of launchers in a different group, then you would have to create a different group. That's the only way. Okay? Hopefully that makes sense. Let me know if you have any questions to sort of explain that better. In this case, I just implemented the Furious Panini, owner Massimo, of course, and stack tags BLT. So you can think of that as just, an easier way to reference that instead of mentioning the backend stack. Well, technically it is kind of correct if you think about this in the real sense, right? If this were a real scenario, then this would be a Python, Linux, and MySQL stack. But this particular panini is made with bacon, lettuce, tomato, okay? And my particular subs, my subnets, I've got 2 subnets for private and 2 subnets for public, and they're just defined all in here, all the other networking information in there. So pretty straightforward stuff. For the inventory side, basically what this looks like when I'm running it is, let's say I've got it all here. So one of the smart people at Arctiq here, I've recorded my demo because I do not trust myself trying to run this, but also because I know that this is a very long one and that takes about 12 minutes to run, and I don't want you to be waiting on me to get this working. So in my particular run for this create playbook, I'm specifying an inventory. Like this one's going to be looking at the hosts for the dev environment, and it's just got those 3 sandwich launchers. And then I'm specifying the extra vars activity equals create, right? And in this case, it means, okay, let's just skip all the destroy tasks and create this thing. And so what that does is it's going to create the VPC, right? It's just the larger group of the entire thing. It's going to create the internet gateways, the subnets, NAT gateways. That takes a little bit of time, so I'm going to just speed through that. And after about, I say 5 minutes, 6 minutes, once that's all created, you get to the near end of this playbook, and you'll see that the the internet gateway, route tables, and NAT gateways are created, route tables are creating, and then you'll see at the very end of that create, all of the destroy playbooks are part of that playbook, or rather, all of the destroy tasks are part of that playbook run. But because we didn't import it because of the activity variable, we've skipped all of that stuff. Okay? And then the same thing goes for the opposite effect. If I were to run activity equals destroy, so kind of like a Terraform destroy, sort of trying to mimic that, then what happens is, yeah, we just skipped all of the creation playbook stuff. So for example, oh, if I can find it here, yeah. So all the first tasks that were laid out in create get skipped, and we move on to the actual destroy piece. So we query the VPC, make sure it's there, query the NACLs, then destroy them, query the gateways, destroy them, so on and so forth. And that piece is a little bit faster than create. Luckily, the only issue that I really ran into was you've got a few, I'd say, a few nuances that I didn't like when I encountered them with AWS specifically. Now, don't get me wrong, AWS is great. I like it. I like using it, but these few things that bugged me was waiting for the actual resource to destroy itself when I clicked delete, or when in this example, when I destroyed the NACLs, I think it was. The network access control lists, for those that don't know what I'm talking about. That was something that when you deleted them, it says, okay, it's going to return. It says, yeah, they're deleted, they're gone. Ansible says, okay, we can move on. But if you looked in the AWS console, the management console is going to tell you, well, it's deleting, and it's going to show up there as deleting, but it's not deleted yet. So you got to wait for it, and you're not allowed to recreate that object until it's deleted on the AWS end. And as far as I could tell, I couldn't find any way to wait on that operation to end. And so to account for that, the only way I could think of was to incorporate a wait, a timeout for that to happen. All right, and that's pretty much it. So it worked out. It took a while to figure this all out, but it was a great learning experience for me on my end. I didn't really, hate it. I think it was a fun experience. It was frustrating moments, of course, but I did learn a lot from it, and I appreciate the learning experience, and I've grown from it. I learned a lot of new, I guess, widely used modules for Ansible, but also some of the niche ones that don't always work so well, but they're getting better and improving every single day, thanks to the community. So that's pretty much it for my demo. Hopefully you guys have some questions for me, but without further ado, oh yeah, just one thing before I cut off. I do have all of this stuff in GitHub, so if you do want to take a look at, my GitHub right here, selfless plug, I do have all this code publicly available, and I do have a README to document it as well as I could to just sort of show you if you wanted to run this yourself, if you have the same sort of idea to provision hardware in AWS using Ansible, then yeah, this might give you an idea, hopefully. And that's pretty much it.
All right,
Yeah.
thank you, Chris. That was great. I'll get a quick look if we have any questions immediately, and then we'll see if we have some at the end as well. Just a quick note for everyone who's on the chat. This is, we're looking at between a 7 to 30-second delay between what we're doing and what you see in YouTube. And that's normal. So if you post a question, we might not see it for a number of seconds, so there's a bit of a delay there. But otherwise, it looks like you're off the hook, Chris, except I might just ask you, have you spent any time doing the same type of thing in the other two clouds, Azure or GCP?
That's a good question, Aaron. I don't think I've done that much in terms of VPCs in Azure and GCP. I've had the experience of doing a lot with Ansible with them, but no, I and that's not to say anything bad about any of the clouds in general. I just never had the chance to, and I think I would love to try that and see what the differences are.
Yeah, I was just curious about some of the differences, like if you'd encounter some of the similar issues with, creates and destroy. Like, I know Azure has a lot of dependency things related to its network groups, and GCP has its own set of rules about its VPCs. I'm amazed they got away with the same terminology, but yeah, it's interesting nonetheless. All right, so let's move out to the agenda. We've got up next Phil Thomson talking about Ansible Tower on OpenShift. So let me reel him into what's going on over here.
Hey
And
guys.
Chris, you get a break. Hey Phil.
Hey, let me get my screen
I
sharing.
can see. Yeah.
How's that looking?
That is the one.
Excellent.
Very good.
Alrighty.
All right. Take it away, Phil.
Yeah, thanks Chris for that. That was a cool little share there. Something else I think too that I've seen using that for is when we're doing webhooks from GitHub into Tower. Again, if you're using GitHub and you've got a repository, there's kind of a webhook per repo. So if you've got multiple branches there, so you've got some Ansible code in one branch, some in another, but you kind of want that webhook to trigger for your one branch. You can have like a main selector playbook that the webhook's calling to, and then filter on what you want it to do based on the variables that get passed through in the webhook. So yeah, that's a cool share, and I guess we've seen it using the sort of GitHub webhooks. And yeah, thanks for having me. This is my first opportunity to talk at the this meetup event. I'm actually over here in the West Coast, so cool that I can participate in the Toronto meetup, which is fun. And yeah, my first time speaking at this too. So I wore my Red Hat shirt and I got my Red Hat mug here, so we can drop some subtle product placements. And yeah, I was just going to talk today about running Tower on OpenShift mainly, and kind of why you would want to do that maybe, and then also once say Tower is running on OpenShift. Some of the, I guess, management operations gotchas, things to look out for. Don't have any cool demos like Chris, so yeah, I'll kind of get through this, and if there's some questions around it, feel free to pop them in there. Alrighty. Trying to make my thing go away. Okay. So a Tower on OpenShift was introduced, I think, in 3.3. So that was back in the end of 2018. So it's been, that option's been around for a while. So it's pretty mature. It's a kind of something that's been available for a while now. It's obviously fully supported by Red Hat to get that up and running there. So it is a good option to go forward. One of the kind of why you would do that is, I think when you're standing up Ansible Tower and kind of a production ready in your environment, right, there's a lot of kind of architectural questions you need to ask and decide. There's questions about like high availability and scale. If this is kind of a production version in Tower, and you're running it as a VM, you're probably going to want 3 VMs there to make sure you can take one out for maintenance, or if something goes down, that Ansible Tower is still up, it hasn't gone down. If that was a kind of for traditional VM, which I think VMs are probably still the majority of the Tower deployments. Obviously, AWX has been containerized, and that's kind of the only option for AWX. But I think Tower, when you're getting installed, I think VM, kind of installing on a VM is the kind of main path forward for that. So if you were installing a Tower on VM and you want to have HA, you're looking probably at 3 VMs that need to get created and stood up, and operating systems need to get updated. They need to all get set to the same, and that kind of has to happen before you get Tower installed. If we're looking at OpenShift, right, this is so Tower is running as a pod. Actually, let me jump over to here, the slide. So Tower is running as a pod inside of OpenShift. And you don't need to create a VM. The creation of the pod happens very quickly, and the high availability and scale features makes it super quick. Because obviously it's a pod, it's a container. Those spin up very quickly and very easily. It is when it gets deployed as a stateful step into OpenShift. So if you wanted to move from 3 replicas to 5, it's a simply updating stateful set, changing that one number to 5. OpenShift's going to see that and then create 2 more pods quick and easily. And this is kind of what the architecture looks like. So obviously the big gray box there is OpenShift. And then we've got the pods. Inside the pod, there's, the 4 containers. And there's obviously the communication between there. And then, this service in. So again, you're running this in production. You're going to want to have, a secure route on there, a certificate. And you're going to have a load balancer, right? So these are, if you've that traditional VM way, right? There's 3 VMs. You're gonna have to, set up a load balancer, get, VIP set up, get a certificate, get that on the load balancer. With OpenShift, kind of that sort of configuration option is kind of answered for you. OpenShift, has routes and has a secure route option that you can just offload. So that makes it super easy. There's not really anything extra to do you need to do there. If you're running this in OpenShift, it's you kind of check that option off really quickly. So again, those are kind of the core features of why you'd want to do that. I think just when you're going through kind of documenting, planning out your installation tower and running a production, the tower OpenShift seems to check off a lot of those things that you would need to do and questions that need to be answered. So that's kind of one of the features that makes getting tower up and running quite quickly. There's not a lot of extra work, depending on where you're deploying tower and what your environment looks like. We see VM deployments can take weeks sometimes in some environments, depending on the change control process. If you need to get firewalls updated, so the network team needs to get involved and they need to have an outage window. You're looking at potentially, designing this and then potentially weeks, months maybe of getting, VM all up and running in production state with, certificates and load balancing. When you're looking at OpenShift, you've got those questions answered very quickly, and you probably don't need to have too much kind of process around getting containers and pods stood up, so that you can kind of get this up quickly, up and running quickly. And that's one of the benefits we've seen with our kind of clients that are running OpenShift, Tower in OpenShift, is there was when we made that decision, getting Tower in their environment in production state happened very quickly, like a week or so, which was awesome to see. You do still need a database somewhere, as is pictured here. That can actually be a container as well too. Probably not recommended for production, but if you're firing some lab and testing it out, similar to the traditional .setup sh to install Tower in a VM. It will create a PostgreSQL pod inside of OpenShift and connect it that way. So that's another quick and easy way to get up and running. It'll have that for you. Again, best practice is have your database outside of OpenShift. Have it, if you're running in a cloud, a managed service would be excellent. Or if running on-prem, you've hopefully got maybe a database team that could help you get a sort of Postgres database up and running and have Tower connect into there. And the installing this is almost identical to the traditional VM install. There's instead of your .setup sh script, there's a setup OpenShift script. Same thing, you'd fill in the variable files, you'd put in information about the database if you were deploying it, information about OpenShift, what's the project name you want it to call, what's the API endpoints, and then the database connectivity information to connect to that. And then you just run the script, you provide authentication into OpenShift. And the script takes care of, creating the namespace in OpenShift, deploying that stateful set, and then having it up and running and connecting to the database and doing any updates. Cool. So we had a quick look at this. Something to note about resources when you're deploying Tower onto OpenShift. So those pods are a bit chunkier compared to, for resource wise, compared to smaller type app pods and containers that are usually a small footprint. The Tower pods, I believe it's six gigs of RAM, 3 CPO is the initial requests for each pod. So again, if you're kind of doing an HA method here and you've got 3 pods running, right, you're looking at 18 gigs of RAM, 9 CPU requests. So depending on your OpenShift setup, how big it is and how big your nodes are, that could consume a fair bit of resources on there. So something to think about. If you're contrasting that to, again, the traditional VM approach, which your VM's probably going to have 2 or 4 CPU minimum, and it's probably going to have 8 gigs of RAM or more. So it's still a smaller footprint than the VMs, which is nice, but something to think about. Okay, so now you've kind of made the decision to get OpenShift running on, or sorry, Tower running on OpenShift. Keep mixing those up, and everything's humming along pretty good, and more people are using it. Kind of what are some of the things we need to keep in mind out for? So one of the things is, now that your Tower is a container, things that you would do in the VM world, like, say you've got an additional binary, maybe someone needs to run a playbook in Tower that has, like, the AWS CLI or the Azure CLI in their playbook. There wasn't a module, an Ansible module, so they needed to just write like a shell thing to do something there. If this was a Tower VM, you'd SSH into your Tower VM, you'd create a Python virtual environment, you'd pip install your required binaries, and kind of away you'd go. You tell your playbook to use that virtual environment. That's obviously not an option if this is now a pod or container. You can't really SSH into your pod and install things. So in this case, what you would need to do is create a new Docker file. That Docker file would be like, the first line would be from the Ansible Tower, so the base Ansible Tower image, and then you'd layer in things you needed. So you'd have a run line there to create a Python virtual environment, and then a pip install to install your thing, maybe like a wget to grab some binary, something that was needed. You would build that somewhere on a machine, and then you'd push that up to some container registry, and then you'd tell OpenShift to, instead of pointing at the default kind of install image that was selected, which is, I think, the quay.io now registry that's pointing at the Ansible, you point it to your external registry or some other registry that would have this image. And then you can just respin the Tower pods and get it to update using that new container. So this is something you probably need to get familiar with, because, as Tower is in your environment and more people are accessing it, when you're running more playbooks, people are going to come and ask, can we have this binary, or my playbook's failing because this isn't in there. So then you need to go through and, update that Docker file, rebuild it, push it. And it's good to have that in an external registry as well too. So somewhere outside of OpenShift. If you're running this in the cloud, it could be like, Azure Container Registry or the cloud container registries, or maybe like a third-party JFrog Artifactory, something along those lines. That allows it just to be kind of outside of OpenShift and can be updated. And it's also nice too that you can, now that your containers outside there, you can have different tags. So you could have a tag with certain binaries or certain versions. And it's nice and easy with OpenShift to kind of redeploy that once your Tower is running in OpenShift and you want to point it to a different container. Again, you'd update your stateful set. You'd change that image tag or that image line where it's pointing at for the stateful set. So which container it's running, which image it's running. So you'd point that to your external registry where you just pushed your updated image. And then you'd scale your nodes down to 0, your pods down to 0 in the stateful set, and then scale them back up to say 3. And then OpenShift sees that it's pointing at a different image. It's going to go grab that and fire it up. So that whole process you'd probably need to get familiar with, because again, that's something that's going to happen frequently. We had and getting used to kind of troubleshooting. Recently, we just had an issue trying to get like Python 3.6, because one of the binaries needed for a playbook had a requirement of Python 3. So we were trying to get this container image updated with Python 3 and get this updated binary in there. Obviously, if that was a VM, you'd SSH, you'd test it out. You could kind of test from the command line, make sure it's all working, and troubleshoot, where you can't really do that from a container as well. So it's just something to get used to if you're not familiar with it. And again, this is nice and supported by Red Hat. So I think Patrick actually was able to help us out and get that Python 3 issue resolved. But again, something, just get familiar with that kind of process. And then having a dev instance as well, super handy. Again, because you can get a Tower up running in OpenShift quite easily. You would just create a project, so a different namespace with the -dev flag on it, and instead of having multiple replicas, you just have one. But that way you can update your container image, test it in a different namespace, make sure it's actually working, and then roll that up into production. And again, you can get kind of clever with the container registry and the tags, right? So you can have like a test or a dev tag on your Ansible Tower container, and have a prod tag, and you can promote your images, so you can test it, make sure that's working in the dev environment, and then update the tag and push it, and then redeploy your prod Tower product version. And one of the other cool things, not specific to Tower and OpenShift, but the containers with Tower, there's something called container groups, and I believe this came out with 3.6. So what this allows you to do is you can run your Ansible playbook on kind of a remote Kubernetes or OpenShift cluster. So a scenario would be, say you're running, say you've got your OpenShift on-prem and your main tower's on-prem and it's running, and now there's a something in the cloud, one of the clouds that you need to run some playbooks against. Maybe there's 10 VMs there in the cloud. You don't necessarily want to open up SSH ports to all those 10 VMs back to your on-prem. So what you can do is you can create a container group. So that container group would say you've got a cluster, an OpenShift or Kubernetes cluster in the cloud. You create a container group in the main tower instance that's on-prem. That container group points back to that Kubernetes cluster in the cloud, and it's got like a pod definition about the pod to spin up. And then when you create your job template, you select your container group to be this remote container group. So then I would click off to fire that job to run it. That would actually connect to the remote Kubernetes instance in the cloud, spin up a pod, pull in that playbook, run the playbook against those 10 VMs in the cloud until it was done, and then it would pass the information back to the main tower instance, and it would kill that pod, and away you go. And then for like the network communication, right? Then you just need to have, a ports open between your on-prem OpenShift cluster and your remote cluster, and you don't need to have your main tower and OpenShift cluster having all those ports open to every VM it wants to run a playbook on. So super handy with the container groups to be able to run kind of remote isolated, maybe it's at an isolated network environment that you've got a separate tower or Kubernetes cluster that allows you to do that. So that's pretty slick. And yeah, I did mention about the resources available, sort of resources in OCP, that it can be a bit chunky, those pods. So just something to keep in mind when you're getting that up and running. And yeah, that's about it. I just was going to keep it brief and just chat about running OpenShift, running Tower and OpenShift. I'm also a consultant at Arctiq, and I deal with lately anyway. It's been a lot of deploying Tower in OpenShift and as VMs and kind of setting it up. And yeah, this is a great forum to kind of share some of the experiences we've been having with that and some of the cool things we've been developing. That's my email. So reach out on GitHub if you have any questions around running Tower on OpenShift or any Ansible Tower questions in general.
All right, thanks, Phil. That was also really good. So, we've been involved in a similar project, taking care of this stuff, and there's a couple other questions that came up. I know that AWX has a slightly different architecture from putting Tower into OpenShift. Have we tried AWX yet?
I've not run AWX in OpenShift yet. I know there's some blogs out there and some ways to do it, and AWX is pretty flexible. I've deployed it into Fargate, which was a bit challenging, into AWS. But yeah, it's got standard Kubernetes definitions and container type definitions. So running it on OpenShift, I think, wouldn't be a problem at all.
Were there any specific OpenShift things about how you deploy Tower into OpenShift that would make it so that it's slightly different to do with vanilla Kubernetes?
I was looking at that before. I don't think we'd have to check, but I don't think any of the resources that created in OpenShift are OpenShift specific resources. There is a route that gets created that is an OpenShift specific thing. So you may need to do something with the ingress in vanilla Kubernetes. But yeah, there wasn't too much there. I think that would be a showstopper. So I'm for sure there's probably some blog entries and maybe some knowledge base articles about running kind of Tower inside of a vanilla kube.
Yeah, and you touched on it a little bit, I think, near the end about having a cluster purely for your Tower, but we tend to talk to some of our customers and lab cases where we would say set up an ops specific OpenShift or Kubernetes cluster. Would you say that it's worthwhile to have a whole cluster for something like Tower, given all the high availability you get?
Yeah, it is handy for sure if that's an option. If multi-clusters is a thing that your organization is doing, definitely having an ops cluster is something to think about. Again, I mentioned about the resource that Tower needs to have a highly available setup. Obviously, you potentially don't want that eating into your kind of main production cluster that's running your application workload. So if you've got an ops cluster there, it can probably be a bit smaller. And you also, there's fewer people accessing it. So, there's the security controls around who has access to what and what pods have permission in the cluster is something that, can be a bit more relaxed from the operations cluster because there's only a handful of kind of ops teams doing it. So yeah, having that ops cluster is a pretty handy path to go through.
Excellent. Okay, yeah, that's all I saw for questions so far, but anyone who's on the stream, feel free to drop any more in and we'll add them to the end of the ending point Q&A. So Phil, thanks for your time. Looks like you get a break, and I'm going to reel in Hart. Hart, you are muted still. There you go.
How's that better?
Sounds good.
Awesome.
So up next, we've got Hart Ripley talking about network automation with Ansible. I'll leave all the intro to him because it's a topic that is near and dear to this heart.
Thanks, Aaron.
I couldn't resist.
All right. Yeah, I'm going to talk about network automation with Ansible, more specifically with Ansible Tower. So first want to jump into some use cases for network automation, right? Things have been done pretty traditionally for a long time in terms of configurations, et cetera, that type of stuff. But now we have automation tools such as Ansible and Tower, where we can streamline some of this stuff and make it a little bit more reproducible, a little bit more efficient, and have some consistency wrapped around that, right? So a little meme on the right, maybe anyone who's been down that road before, can be pretty daunting and very difficult. A lot of ad hoc requests and config changes and that type of stuff, and not really a great visibility over the network as a whole, different types of devices, that type of stuff, right? So I'm just going to quickly go through some of the general use cases here, right? A big one is configuration backups, right? So something that's not traditionally done as often as it should be or at all, right? Ansible provides, a fairly easy mechanism to get that up and running. Backup configurations for different vendor devices, store those securely, versioning, this type of stuff. So pretty simple use case, but definitely helpful if you lose a device and you at least you'll have a backup to come back from, right? So upgrading firmware. Obviously, there's some things to consider here when you're doing that, like downtime, et cetera, but gives you a very predictable and repeatable way to update firmware across multiple vendor devices, right? Not only that, but also verify what firmware is running and really could be action to only upgrade those devices that are not at a certain version already. I'll talk a little bit more about scheduling, but scheduling can also factor that into that as well, right? Where you can say, I want to upgrade my firmware off hours and minimize downtime, and that's something that you could utilize through Tower. Reporting, right? So nice reporting options within Ansible where you can kind of write your own reports, pull out the information you want based on querying some of the devices, right? And output that in various different forms, right? To the screen, to a chat app or something of that sort, and get some kind of real-time data around what's going on there. And as well as documentation, right? We want to have that like a living, breathing thing now. When we're talking about source code management, right? Having that in like a Git repository where it's always updated. It's updated by a playbook job versus a human going in and updating a Word doc, and then it's out of date right away, right? So I talked a little bit about consistency already, but that's a big thing, right? Where your Ansible your playbook is structured the same way. You're pulling in different variables, and it's going to be run the same way every time on different types of devices, this type of stuff. So tying back to Git, right? Single source of truth, having your configurations, your variables, all your settings kind of in one spot, right? And that's controlled by workflows and other forms of credentials there. And then blueprints, right? So when you're bringing a new networking device, how do you get it up and running, right? Is it, you don't take a configuration from another device and try to modify it and apply it to the new one, right? Obviously there's room for error there, and at the end of the day, it's really not a great way to do it, right? We want to start from something where we say we have a base level config, or a standard set of configuration plus variables that we can lay down on that device. So still lots more use cases there, but those are just some of the general ones that we see, and ones that are fairly easy to get going. So why does Ansible make sense for networking and network automation? I mentioned already is multi-vendor, right? So we're not tied into a single product to support one vendor type of network devices. We can interact via one playbook or a role against endless amounts of vendor devices, right? Based on variables, connection types, and obviously conditionals. So super flexible there. We can consolidate onto one tool and manage multi-vendor devices, right? We can get earlier when I was talking about configurations, right? We're getting more now to the network as code, right? Where we can have our network configurations stored in Git, right? So that's the source of truth. And basically, this is what we want it to look like. We can have Ansible instantiate that on the devices, right? And ensure that it's always applied and it always meets and ties back to what we have defined in Git, right? And one of the big selling points of Ansible, obviously, is we don't need an agent network devices unless they're Linux-based, and then could be difficult. We don't want to be installing an agent on the endpoint. The nice thing about Ansible, it gives us the option to interact with that network device, make changes, et cetera, when we want to, right? When we decide we're going to run that playbook or job. Tower. So one of the big benefits of Tower is you get the role-based access control, right? So we don't have to rely as much anymore on creating user accounts on network devices, managing that with something, ensure they're consistent, right? If you have 1,000 switches and you want to give someone access, it's potentially a new administrator or a certain level of access, you need some way to orchestrate that. If you have multi-vendor in place, it's a lot more difficult to do that. Ansible, we could orchestrate that fairly simply. Or use Tower to interact with those devices where it has the rights to do stuff and you have specific rights within Tower. In integrations, right, there's a lot of integrations for Tower. Obviously, Git being one of the main ones that we need in terms of foundational code and giving it something to actually run. But a lot of integrations for notifications and webhooks and stuff like that. We'll touch on that a little bit more as we go. Consistency, already touched on that, right? We're doing stuff in a predictable way, time and time again. So for anyone that's familiar with Ansible, you can see on the bottom here, typically with Linux hosts, the Ansible control node, it could be Tower as well. When it connects to these remote hosts, right, it's actually copying code over to it and executing locally on that remote host, right? Very different with how the Ansible or Tower control node interacts with a network device, right? Network device is, we already mentioned, we can't install an agent. We're not really copying anything over. We're executing everything locally on the control node. And we have a tunnel opened up to that network device, orchestrating what we're asking it to do in the playbook. So we do have a bunch of different connection types that have been introduced for network devices, right? We still have like the traditional SSH piece. In the network world, we're using a connection type of network CLI for the majority of the use cases. It definitely depends on vendor as well, right? Some vendors only support certain connection types, which is all documented in the Ansible network documentation. But yeah, traditional SSH, we're keeping our sessions open, this type of stuff. netconf, different format. You'll find stuff like that on Juniper devices where it's going to use netconf. And then HTTP, so more so exposing an API. So you're going to see this more on some of the newer devices, some of the more software-defined devices. And that API, typically most devices support the API integration, also support the network CLI piece. And then local, that's the way it was done up until some of these other connection types came into play. Basically everything's executed on the control node and you're over SSH. So every time you need to interact, you go open a session, right, and run your tasks or plays that are involved there. So a bunch of different connection methods. You'll need to make sure what works with whatever device you're interacting with, but a couple different options there for sure. So I want to quickly highlight, why Tower makes sense. Obviously Ansible can do the job in most cases, but there's some areas where Tower provides a lot more value around, multiple devices and scale and this type of stuff that we had mentioned previously. So one of the big things is credentials, right? If we're using an Ansible engine on the command line, where are we storing our credentials? We could doing it in Vault. We could be doing it when we run the playbook, right? Both of these have room for credentials to get leaked out or be in the history or something of this sort, right? And managing Ansible Vault is fairly cumbersome as well and doesn't scale very well. So with Tower, we mentioned already, we have the full RBAC suite there and the credential store. So Tower has an encrypted credential store where we can store more than just credentials, right? We can store other secret things that we need to integrate with our network configurations. And obviously it's centralized, so it gives us a good spot to pull stuff out of, and we can manage the secrets there, versus potentially lots of them on the network devices as well. Source control, we talked about it a little bit with the, if you're running Ansible on the command line, a lot of the time you may just quickly create a playbook and run it, and it never gets into source control, never gets versioned. There's really no trail of what you did or how you did it type thing there. Tower drives the approach of tying back to source code management. So anything that you're running in Tower is coming from a repository somewhere, right? So you're getting the versioning, you're getting the history, all this type of stuff. Control node, right? Ansible engine is wherever you're running Ansible, your client machine, a server, this type of stuff. So more so than not decentralized. And even if it was centralized, it's very difficult to manage and ensure consistency, as I just mentioned. So, and Tower, obviously, centralized already, and it will pull in all the repositories and be able to securely store the credentials for access to all those repositories. User experience, so command line, obviously for Ansible engine, pretty straightforward. Everything's run that way, and you need to figure out how you're going to develop in this type of stuff. Tower provides the GUI, dashboards, API, all the other features that are going to give you extensibility and integration with the platform. And just some other points for Tower over the traditional Ansible engine. We talked about integrations already, but scheduling is a big thing, right? If you want to have playbooks that run off hours, gather results, check the status of your devices, make sure everything's kind of running and available. Scheduling is pretty powerful. You get your auditing, logging, see who ran the playbooks, the job templates in the Tower world, when they ran them, kind of success, failures, and dive in a little bit deep to that versus, if you're on the Ansible engine, you'd have to dig back into logs, even if you had any sort of verbosity there. So API is a big thing, right? This really plays into the integration where we can say external systems can call Tower and kick off jobs, right? So you can create workflows from that perspective. And clustering, Phil kind of covered off that a little bit already. We have the ability to add multiple Tower worker nodes and make sure that the availability is there if we're relying heavily on Tower for automation. And Tower, what I want to get through here is the point that Tower, becomes more of the network administrator, right? It allows the administrator to focus on, creating new designs, focusing on architecture, not break fix stuff all the time, right? Tower can take away some of those repetitive tasks that provide, some insight into the environment, the documentation, the availability, this type of stuff, right? We talked about the credential store. We can have all our keys in Tower, right? We don't have to distribute accounts out to everyone. We can have Tower orchestrating against the network devices versus you connect to device A, device B, device C, right? You run what you need to do. Maybe you do it the same on all the devices, maybe you don't, right? So Tower provides that centralized capabilities as well to handle multiple vendors as well in the same environment. And RBAC, we talked a lot about that already. We can decide different levels of people within the enterprise, what they can actually do in Tower. Can they just execute playbooks that are predefined? Or do they have more administrative access where they can add playbooks, add inventories, add credentials, right? All that stuff is available by using the Tower RBAC. And maybe we can get away from, in some cases, having to define, TACACs and all this type of stuff as, we can extend the RBAC or what someone can do to, a team or group and have that network wide based on whatever Tower's managing. Consistency, we're always pulling from Git, right? So as long as Git's up to date, you run your Tower job, you're running the latest playbook, the latest variables, this type of stuff. So you have your single source of truth, and Tower is just going to work from that, right? So there's going to be no drift or anything of that sort. And then workflows, right? So Git is a good way for the history. We can create, pull requests, handle all those issues and merges and all this type of stuff through Git. Have all that history there, and then at the same time, orchestrate Tower directly from Git. And then some of the extension of the use cases is we can run reports, do config checks, and just kind of see, are the devices available, and report on that type of stuff. One of the big things with Ansible is Jinja 2 templating, right? So this really plays in well to the networking piece, right? As basically different groups of devices or even different devices themselves may have different configuration, but we can still configure them in a consistent way, right? With consistent templates by using variables and various Jinja templating blocks there. So just a quick snip here. This is more around like entire configuration or blueprint configurations, right? If we have different groups of network devices in one location, right? They may have, different system settings, different DNS servers, NTP, this type of stuff. This is a very easy way to do it with variables, right? As the configuration is going to get generated by the playbook run, but whatever variables you have set up for that group of hosts or those individual hosts will get pulled in and templated in that manner. So it's good for interface configuration. It's good for entire configurations. Both those use cases apply. So I'm going to jump into a little bit of a demo here, and then I'll finish off the last slide there. So I have a Tower environment here. I want to highlight a little bit about the Git workflows that I was talking about there, right? How we can orchestrate code updates and publishing to the master branch and this type of stuff, all handled through Git. Actually, go through here, quickly show here what we've got, right? So we talk about variables a bunch, right? So we've got away from connecting to a device and making changes directly on the device, right? Now we're variabilizing stuff, templating stuff when it comes to a network device, and we're able to instantiate it that way, right? So we can see here we have a bunch of group variables defined for this Cisco device, right? We're going to use a playbook to say, okay, let's template this out. Let's go to the device and apply it to the device if it needs to be applied, right? So we're not just going to go and write it every time. The nice thing about a lot of the network modules that are available for most of these major vendors, they have some intelligence built in, some idempotency. So we have the ability to basically update what we want to update, but in typical Ansible fashion, if it's already in that state, then we don't need to change it. All right, so I'm going to go through a workflow and just create another branch here. What I'm going to do is I'm going to take on this Cisco Nexus, which I'm just going to add some interface configurations here. Create a quick branch here, right? We don't want to be interacting with master. In the perfect world, the master branch should be locked. And if we want to make any code changes, add a switch configuration, for new devices, this type of stuff, we'll create a new branch. We'll add in our configurations, and then obviously through the pull request and the merge workflow, there's going to have to be some reviewers to say, okay, yeah, this looks good, and we're going to instantiate it on the devices. The nice thing about that is it's all controlled through Git. So if we need to revert to the previous commit, we're going in and clicking a button and firing off a Tower job. Right, so it's a pretty good trail there in terms of being able to make those types of changes. So I'm just going to make the changes here in the GUI, just for visibility here. All right, we have our group vars file with all our interface configurations. All right, so let's just add another configuration to a switch port. Right, we don't have them all configured here. So let's make a quick edit here. Just going to add a port configuration, right? So basically bringing that port online, assigning it a client number, right? And then if we want to go as far as well, we're looking for VLAN and types. All right, in this case, I'm not going to apply that, but you could light up the switch port on a specific VLAN as a layer 2 switch port, layer 3, whatever you want. All right, we're using an interfaces module, which will support both based on the arguments you put in the module, or the parameters. So here I'm just going to add another interface, right? I'm going to commit this right here, right? Remember, we're still in the other branch, right? We haven't impacted master at this point in time, right? We're still working in this other area. So now if I want to commit that, right, we can go and create a pull request. All right, we want something a little bit more descriptive here. In this case, I'm only doing it on one device, but this could be across multiple devices, depending on how the vars were set up. I just wanted to provide a kind of an overview of a Git workflow, right, and how we interact with Tower from that front. Right, so we're going to do a pull request. We're going to try to merge this interfaces branch into master. All right, I'm just going to override here because I have this repository set up this way, but ideally this would go to an approval workflow. Someone would have to review it. Someone would have to merge it in, right? It wouldn't be the creator that would be doing something like this. So I'm going to merge this in. All right, so now we go back to our master branch here. Right. Pop into our group vars folder, right? We can see our latest commit. We have our interface here, right? Pretty straightforward. The one thing that we've typically demoed before is a webhook integration, all right? So what we can do with the Tower API, and now that it's supported directly in Tower, is if we go into our job template, network device configuration, right? We can enable the webhook right here, right? So pick your service, we'll generate the credentials and all this type of stuff, and we can add that in. In that case, we can say, okay, when we're merging this branch into master, we can kick off this job in Tower, and it would go lay down that configuration, right? So there's no coming in here and clicking launch, right? You already have everything done in Git, and Git drives that entire workflow, right? So I'm just going to kick this job off here. And I'm just going to jump over to the switch here real quick, and we'll see we have the current configuration of this interface, right? Shut down, no configuration. I didn't put a VLAN on it in terms of what I was showing here, but basically what we can do here is we can define it as a variable and template that out, and then have the playbook run that against the device, right? In most of these playbooks, we're backing up the configuration first, right? Obviously, Git has the latest revision of the configuration, so it's pretty straightforward there. We always have a fallback plan and that type of stuff, right? And what I'm putting here with the debug is all I'm doing is anything that was updated, right? So we can see that it's marked as changed because we're adding something to the configuration, and we're saving the configuration, but we're just outputting what was actually applied. And this is the stuff that we put in the variable file within Git, right? So we can pop back to the switch here now. Right, and we can see now we have the port labeled, right? It's not shut down like it was before, right? So it's active. It would need additional configuration, but for the purposes of the demo, just kind of showing kind of what's possible there. That's what we're trying to show with really any of these demos, kind of what's possible, right? And get some ideas in your head around different use cases for Tower and the automation side with the networking devices. So I have a bunch of other stuff here. We were talking about reachability, right? So what's in our inventory. It could be a dynamic inventory, it could be a static inventory, it could be, Cisco devices, Arista devices, really any network device in the inventory. We can have a single playbook that connects them all and make sure, are you online, right? And based on success or failure of that, you can output a notification to Slack or, email, write a report, this type of stuff. So this is a good use case for like a scheduled job, right? Where you could run it on a nightly basis or every couple of hours or something like that versus, obviously you should have other monitoring systems, but just to do health checks and stuff like that, you have the option to do something like this as well. I'm going to jump over into another session here because I want to highlight some of the RBAC stuff around Tower, right? When I was talking about teams earlier, basically we're able to, build in different tiers in terms of teams and tie them back to different groups, right? So, we can now, give more granular access to, groups that aren't even in the network field, but need to gather information like help desk staff or something like that, right? Where they would want to say, okay, I need to triage these devices in this location and I need to get some more information about them so I can, kind of build my case and see what's going on and start drilling in from a troubleshooting perspective. So the nice thing about we don't have to ever give non-network users or non-admins access to anything in terms of network devices. We can give them access to Tower and they can come in and run a playbook, right? So what I've created here is just L1 network admins with the help desk user, and they have limited permissions to execute job templates only. Right, so I'm going to pop over into this browser here and re-log in. So when we're going to log in here, the nice thing about Tower and role-based access, I don't see any of these system stuff, right? I'm only seeing the jobs that I just showed you I have execute access to, right? So let's go into this report job, right? We see everything's grayed out. I can't change anything. I can use and execute the job. Or the specific playbook, but I can't actually change anything, right? I can't see any of the credentials. I can't do anything, right? So it's very granular in terms of what access you can give to someone, but still have them interact with network devices, right? These are all read-only playbooks, right? So they're not actually making any changes. A lot different than the one we just did where we executed a change against an end device, right? So, typical gather facts, very similar to what you do with like Linux machines, et cetera, right? There's a bunch of network modules for gathering facts, right? These will reach out, they'll use the different connection types I talked about and, pull in kind of what you defined or everything that you define, right? We have Cisco Nexus device, we have an iOS device in this case here, and we also have a VIOS router / firewall, right? So we're able to run with a single playbook and get some facts about our devices, right? So if we drill into the iOS device, and this is the nice thing about Tower, it makes it easy to drill in and get some information back, right? We can see some quick highlights of, the IP address of this device, what model is, what it's running, serial numbers, this type of stuff, right? So obviously you can see where this is going in terms of reporting and dynamic documentation, right? It gives you a lot of flexibility there, right? The great thing is we can see and think about this from like a help desk perspective. We can see what the interfaces are down or up, right? So if there's some way to correlate which interface a user would be connected to, you go in here, you run your playbook that kind of triages the interface and you see, okay, it's down. Well, then you have a starting point to say, okay, maybe the cable's unplugged, right? Just a very simple example, but just to kind of tie it back to the use case. And then this limited user here, sorry, I'll go back in here, right? We have device reporting, right? I'm just doing a simple report here. We kick this one off just to get some additional information about the device, right? In this case, we're using, so we have a report role here, and we're just templating this out with Jinja, right? And this is what we were doing before. I showed you this in the slide. Basically, we were taking that list of interfaces that we had in the variable file there, and we're just templating this out. When we go to actually apply it to the device, it's going to have the entire list of interface, but the module is going to understand, okay, all these interfaces are already configured based on what you have in this this output file. I only need to go and configure 4/20 in our case, right? So let's pop back to Safari here. Right, you can see we had our report run. Right, we're running it against a couple different devices again. Right, we're doing the two types of Cisco devices in the BIOS here. And we're generating a network report. I'm just outputting it to the screen and for the purpose of the demo, right? So we can see firmware versioning, the name of the switch, a whole bunch of information around what's it booting from, serial number again, like a little bit more extensive than what we saw with the previous gathered facts, right? So, and we're templating that out into a human readable format, right? So we control over how this looks. This could be output to email or Slack or something of that sort, right? Something where someone could see this, or save somewhere else in terms of version control, so you can kind of see, what was the report yesterday versus what is the report today, right? So pretty straightforward there, showing the different levels of access, right? This user can't create any jobs and can't do anything in Tower. They can log in and they can execute stuff and get information back, right? We have a reachability job, very similar. It's just gonna kind of get to the device, kind of respond back. Can I open a secure connection to it? So that's that. The one last thing I wanted to talk about quickly, because this is a big thing when it comes to Tower, is credential store. Right. So within Tower that I was talking about earlier is we're allowed, or gives us the ability to have encrypted credentials, right? So we can use, we can add in here, but we can't go in and retrieve them, right? So we talked about this network CLI connection type. Well, I'm not masking out the username because it's fairly trivial. We could, but the password is in here and it's not retrievable even by the admin user of Tower, right? We can replace it, but if we don't know it, we don't know it type thing. So it's a nice central place to store credentials. If we're interacting with hundreds or thousands of devices, it gives us a lot of flexibility in terms of where we need to store the credentials, how many service accounts we actually need, this type of stuff, right? And there's ways to rotate credentials inside of Tower as well, right? So that doesn't get away from any of that compliance stuff. And then, similarly, like SSH keys in here as well, right? So if that's how we're connecting network devices, perfect, right? A lot of different options there. And then there's a bunch of built-in credential types, and those will work depending on what they're filling out in terms of username and password variables, right? And that's dependent on, the type of device and what network connection type it's using, right? We can see real quick here before we wrap up is that we're also defining the network OS type. So Ansible knows what it's talking to and how to connect to it, right? So, and actually while we're here, this is a good point, right? Ansible user and Ansible password, right? So these are the variables that Ansible is going to utilize the values from to connect to the device. Where are we getting this from? We're getting it from an environment variable, which is coming from Tower, right? So we never have to worry about storing anything secure in terms of credentials in Git repository, but all our code is in there. When the job runs, right, we're pulling it out of this, of these fields here, right? So Tower will populate those variables, run the job, destroy the environment, and you'll have your kind of success or failure of the job at that point in time. So it's really what I wanted to highlight there. Just obviously the benefits of Tower and multi network device, a different vendor environment, centralized control, and then having the ability to do role-based access on the Tower level versus having to do it on the network level and manage that across multi-vendor. It's pretty challenging. So a lot of different use cases there. And just to finish off here, let's pop back to the slide. Yeah, a bunch of open source options when it comes to networking, right? Most people have heard of OpenStack, but it's pretty extensible in terms of Ansible modules. There's a lot of integration there. And a lot of capabilities to do automation on OpenStack. Cumulus, so if you have your own switches, you can put this network OS on there, manage it with Ansible as well. It's quite well documented, and it's these are nice options if you want to do something in a lab. VIOS as well, free online, download that. Router Firewall gives you a lot of a nice test bed in terms of a lab to run some of this automation, right? So there's modules for all these different types of devices. And then, if you go to Linux Foundation, you can see a bunch of other open source networking options, right? If you want to get your feet wet with some of that stuff. But really Ansible, is configurable, and pretty much you can do what you want with it. if you spend the time and build the code. So the nice thing is on the network side is, it's very flexible as well. A lot of the vendors have great modules. Some of the vendors are still catching up. Some of the vendors, don't have, full module support for everything. But at the end of the day, if you can connect to it via SSH, you can still orchestrate against it and run commands, right? So here's my contact info. Definitely check out our blog. There's a bunch of stuff from past networking events that we've done around some of that code and some of those workflows and some additional networking device types, right? If you want to see some demos. And then, there's a pretty low barrier if you want to get Ansible and start implementing in a lab against some of those network devices that I just previously showed. So that's it for me, though. Thanks, everyone.
Excellent. Thanks, Hart. That was a really good one. There's a few questions that came through via various channels, so we'll get through some of them. And I think what I'll do is I'll also just reel in the rest of the team and try to attack them kind of in a mixed mode. So here is Chris and Phil coming back. Hey, guys.
Hey.
Hey, nice to be back.
Yeah. There's just a few that came up for Chris kind of near the end of your presentation. I want to get to those. One of them was, have you considered using the Ansible CloudFormation module when working with AWS? Curious if there's a reason why you went with your approach versus CloudFormation or what have you.
It's a great thing that I went first so I could look into this and answer it correctly. But for real, back then when I was working on this project, I think it was more of I knew it was a thing. I knew that CloudFormations was another way we could probably use or implement this. At the time, I didn't spend the time to look into it and see how maybe that would help implement just the VPC portion. At first, I really thought, we had all the modules we needed to accomplish this. It shouldn't take that long. And I sort of geared away trying to incorporate any of AWS, their specific support for automation. That's a fault on my end, because in hindsight, if I did do it that way, it might have saved me a lot of time. And it's not even a scenario of trying to be cloud agnostic, because even with Ansible, whether or not we use the AWS specific templates from CloudFormations, with Ansible you're still going to be using AWS specific modules anyway. So that's definitely something I'll take a look at next time if I have to face this problem again. Similarly for the other clouds like Deployment Manager and GCP, or the templating one, Resource Manager in Azure. It's the same concept, right? So I'll definitely take a look at that.
Yeah, I was going to say, like, you can do ARM templates, I think, with both Ansible and Terraform when you're working with Azure. So you have a lot of different ways to approach it depending on how cloud agnostic you plan to be or not. So yeah, it's a good thing. And then the other question was, and I think this was in reference to the way you were writing it so that you could do destroys and creates. Have you ever tried to include the tasks by tag value instead of referencing different playbooks?
Yeah, that was a very interesting one. It was a nice way to sort of approach it. I think we just went with trying to go with what the customer wanted in terms of value. And I don't know how much extra configuration or control over that creation would be beneficial to the customer. As far as we could tell, they wanted just the ability to create and destroy all of the resources. But then if we wanted to maybe improve on that and say, we just want to do some sort of interaction with only NAT gateways and that sort of thing, we could probably implement with tags and have a few flips, switches like true and false in the inventory that says, okay, we're dealing with just creation or deletion of the NAT gateways here, and then run that playbook. That's actually a very interesting way we could improve on the playbooks for sure. I just think maybe for the customer it wouldn't be that valuable for that particular engagement.
Yeah, it makes sense. Yeah, there's different ways you can go about doing, mass create, mass destroy, and stuff like that. I've used tags before when I was trying to debug, particular sections of a really complicated set of roles or playbooks. So that's fair. The next few questions are, most of them came out during Hart's presentation, but I'm gonna just say anyone can jump in and try to talk to some of them. So like one of them was, what is kind of and I guess pardon the networking pun, the gateway task or the easiest way to start automating with network?
Yeah, I think it's really, you need some sort of lab, right? We use GNS3 a lot, right? Because it's free. It's, you can run it in VMware, you can run it in your local machine, whatever hypervisor emulator you have. And then, you can import your images. It's pretty quick. Some of the images for some of this open source stuff are free online. So you just download them and put them into GNS, right? Give it an IP address. And obviously you need some sort of node running Ansible, right? Linux machine or, some sort of Tower AWX, but it's pretty quick. There's a lot of decent examples in some of the modules online, right? Some blogs and stuff like that in terms of how you actually interact devices. I find when you're starting out, the hardest thing is to actually get connected to the device, right? And figuring out what you need in terms of connection type. Where do you store the credentials? How do you apply the credentials? What credential variables does it want? This type of stuff. So once you get that stuff out of the way, the module documentation is pretty decent. As I said earlier, every vendor is different in terms of where they're at in terms of maturity, right? And I think on the Red Hat side, they're starting to move a little bit more towards a more modular approach for multi-vendor, right? And making it a little less decoupled, right? So I would say, GNS3 is pretty good. If you obviously, if you're not a hardware person, if you have hardware devices, then, you can go down that road, but you're gonna have to do a lot of physical work at that point in time. So it's pretty easy to do everything virtual. You can even light up GNS in the cloud environment if you wish to, right? So just fairly heavy resource requirements, but if you're just running a couple switches, you can do a smaller, slimmed down version of that. So it's usually where we like to go because it doesn't just end at network devices. You can add in servers and everything else into the same sort of project structure. So it's pretty flexible that way.
Yeah, I think you might be answering another one of the questions. You probably would say the same thing, but do you think that a dev network environment is worthwhile to have, or is it better to just lab it out using something like GNS?
Yeah, dev is good, but if it's coming down to hardware devices, you have to manage those devices. You have to, procure them, this type of stuff. Like GNS, the nice thing about it is you can also automate the stand-up of GNS, right? So say you wanted to test something new on a bunch of different devices or test some firmwares or something like that. You could automate your GNS server, have it up and running for, a couple days. You restore your projects from somewhere, right? Cloud bucket or something of that sort. And you're up and running within, 30-ish minutes, right? You have your full network environment. You can add different switches. You can try new vendors, all this type of stuff, and tear it down when you're done, right? So a few different options there. And I think that makes it pretty good in terms of labbing experience. If you have the luxury of having a bunch of like real network devices, then yeah, sure, use those. It doesn't really matter. It's just if you break them, then you have to physically go to them to fix them or have a console. So
there was another one about open source Ansible. So the question I think is about couldn't you use Ansible Vault for encrypted variables for those using open source Ansible as their starting point? You probably could, I imagine.
You could, yeah. Like there's nothing to say that Ansible engine can't do anything that Tower can do aside from like the RBAC and stuff like that, right? It's more about ease of use and this type of stuff. Like if you want to jump into a command line and do something, you know what I mean? If you're doing Vault, you need to add all your other flags and stuff like that versus just run the playbook. So yeah, it'll work, sure, but you need to still be storing those files somewhere, right?
I would say, just to jump in there a little bit, like there's one convenience to it, which is if you're using Ansible Vault on the engine side, just core, you're still gonna have to plug in your password every time you run the playbook or expose it as an environment variable, which is maybe not the best thing. That's just my input there.
Yeah, and the nice thing about Tower is when you do that, it's just for the duration of the job run, right? So it kind of takes away that, oh, am I leaving something in my history or something of that sort? So yeah, it drives the reasoning even more so, right? So, but yeah, you can absolutely do it with Ansible Engine, and it's a great way to test quickly. And can kind of get up to speed, but obviously, like, store everything in Git. Don't keep it all in your local machine. Like, use some sort of version control, whether you're using Engine or Tower, right? So.
Yeah. And then there was another one. I guess this kind of is kind of out for anyone to answer again. Does anyone have any network as code or network automation project stories with particular interesting points to talk about? Maybe think about that for a second.
Thanks for all the commentary there, Patrick, too. That's some pretty helpful and good perspectives.
Yeah, he's adding a lot of color to our chat. This is good.
Mm-hmm.
I guess you have one, Phil, yeah?
Yeah, if you want to switch over to my screen there, I was going to just show the Docker file we used.
Oh, yes.
Yeah. So someone was asking about if that image is available. So it's on quay.io. It seems to be freely available. There's nothing locked down, so I think anyone can go just do a Docker pull and grab that if they wanted to kind of play around. And this is what a kind of the customized image would look like. As you can see, we're starting with that main Ansible Tower image based on the specific version of Tower. Then we're creating a directory for our Python virtual environment where we enable the virtual environment, and then we add a bunch of things we need. The one gotcha we found when we were doing for this with Python 3 was it's kind of weird. You needed to kind of install Ansible inside of Ansible, which was a bit concept, wrap your head around. So that was being the one, as well as this PS utility. We were getting some errors around that. So I think if you're making a custom virtual environment with Ansible running as a pod container, those two things would be good to install in there. Yeah, that was it for that comment.
Looks good. Appreciate it, Phil. And then let's see if I have any others here. This is a good one for everyone. How do you think idempotency, like writing for idempotency, differs between network versus compute infrastructure?
Well, I can tackle that from both sides. Like, I think on the network side, it's very dependent on the modules, right? Some of the modules are natively idempotent, right? Even more so now, but some of them aren't, right? So you need to tackle, are you going to do conditionals, right? Are you going to do some sort of gathering information about a device and doing it that way, right? To see, are we going to execute this or are we going to skip it type thing? So there's both of those things you'll come across. It's not like if you're dealing with Cisco devices, they're pretty good in terms of that idempotency perspective. And then like servers, again, like Linux endpoints, the idempotency there has been baked in for some of those modules since the start of Ansible, right? Like writing files and this type of stuff, like that, the idempotency is native there. So I think there's probably a little bit more already laid down in some of the native Ansible stuff and some of the older modules than the network side. But like the network side is definitely caught up in the last couple of years. So it's getting better, but you need to check the documentation, and it really is still vendor dependent. Some of the modules, like some vendors have 100 modules for networking devices and other vendors have 2, right? So you can kind of see who's got skin in the game and that being said, but it varies. I can't really say for sure if idempotency is there, you would need to kind of dig in and dependent on what you're interacting with.
Yeah, I'd reiterate that a lot. It's really dependent on the modules, how much support they're getting. For me, I didn't really notice much of a difference. Like, you're getting idempotency as if the same way as if you were deploying a VM, right? If the network is there, the VPC is there, then you're not going to recreate it. Except for in my case, when I did it and I had 2 machines or 2 hosts that were trying to provision the same VPC with the same name. And keep in mind that we're not able to specify the unique IDs or anything like that. It's just based off of name and some other attributes. that we're querying on the AWS API side. And if it's already there, then it's not going to create it. Otherwise, create it. But in my scenario, it was creating the exact same named VPC with the same components, and it was trying to create it twice at the same time, and it did create it twice at the same time, unfortunately. So I had to account for that. But for the most part, no, it's pretty good in terms of idempotency.
Fair enough. Yep. Anything to add, Phil? Or pretty much agree there?
No, nothing to add on that front yet.
All right. It looks like we're pretty much ready to wrap up. Thanks everyone for doing those talks. We covered a lot of what I think were key and current topics that we keep getting asked about, and we just kind of never wound up talking about them until this one. So this is great. I think there was a lot of good feedback. We had a good number of questions come by, and I'll just throw out here that here's all of Ansible, our website, Arctiq, and OpenShift. If you're looking for some of the code that we share on occasion, we do have sort of a subfolder inside our org repository called, I think it's called Community Events, where you can see some of the open source code that we dropped in there for past projects, past meetups, past events that you've seen with us online. And I'm also going to plug that Arctiq is actively hiring if you're looking for some interesting, really new tech to work on, and always have some different things to do almost every day. That's kind of what we do, and we work with automating all the things. This meme could not be more astute for how we like to think. It's old, but it does its job. So thanks everyone for tuning in. We're gonna drop off pretty soon, but feel free to stay in chat if you have any other Q&A to do. And again, see you the next time we schedule an Ansible Toronto meetup.
Thanks, everyone.
Thanks, everyone. See ya.
See you later, everyone.